Yes, sir.
Okay.
Yes,
So
sir.
okay. So we'll complete this OSI model. So open system, interconnect. It is contains 7 layers: application layer, presentation layer, session layer, transport layer, network layer, data link layer, and network layer. Okay. Data link layer, network layer, physical layer. So this is the first layer is application layer. Application layer is dealing with a application side. It means client side application, server side application. Client side means like a web browsers. Outlook is nothing but a mail client application. Putty used for a SSH or using SSH or a Telnet protocol, we can able to connect remote servers. FileZilla, cuteFTP, these are for connecting to send and upload a remote download kind of stuff. RDP, okay, RDP protocol, MSTCS, MSTSC, MSTSC. If I type like that, it shows remote desktop connection. Okay, so it's a client side. What about a server side? Web server application like a Tomcat, Glassfish, Apache, HTTPD, NGINX. These are all web server applications. Mail server application like a Microsoft Exchange, Zimbra, Squirrel Mail. These are mail server applications. Telnet server means Telnet servers. SSH server means based on that in system we install SSH server application or Telnet server applications. So then we can connect, right? Server side application is there, client side application is there. To communicate between this client to server or server to client, so how they will understand by the protocols. Like a web related communication means HTTP, HTTPS. Mail related communication means SMTP, part2. And that three things depend. Client side, application, for example, web browser, use to access website from the web server. Their web server application. And between how they will understand HTTP protocol. Okay. So all three things should be matched. The client should be server and the protocol. These three things should be matched to the communication. For example, I use a FileZilla and I want to use NTP protocol. Mismatching, right? Different protocol, different type of. I use FileZilla to access a mail with NTP protocol. It not matching, right? So three things should be matched. Client application, server application, and the protocol. These three things are matches, communication happens. If not matches, no communication. Okay. Understand the point, guys? Okay.
Yes.
Very good. Next is
Yes, sir.
presentation layer. Very good. Okay. Next is presentation layer. What is the presentation layer? We'll do it. So whatever the types of communication it is, either you are sending a mail or maybe uploading for downloading file, or maybe you are accessing remotely. So what it will be send and receive? The data, right? The data can be any format. Maybe HTML format, text format, JPG format, GIF format, MP3 format, MP4 format, or streaming like FLY format, SWS format, okay, PDF format. Data can be any format. What is this presentation layer do? Presentation layer is also part of your software layer only. What it will do, it convert your data into ASCII format. Then it is converted into the binary format which your system can able to understand. Because ASCII is directly converted into the binary coded decimal kind of stuff. Okay. Application and data is encoded. It converts your data into ASCII file. It compresses the data. Data is the size is bigger, then it is compress the data, so then it is easy to transmit. Encrypt the data. Encrypt the data. What is encrypting the data? So if you are using HTTPS or maybe SSH, so data is encrypted. So when you are transmitting data from one place to another place, instead of sending in a plain format, we encrypt the data to send it. Encrypting the data, decrypting the data is happens at presentation. Session layer, it will create a session, maintain the session, and terminate the session. And there is one more point that is called authentication. For example, I want to upload a file to my remote server. First of all, I have to connect it, right? So when I'm sending a request, it asks username and password. You give username and password, it authenticate. Okay. Once authenticate, the session is created like with your session only. First, make sure that is allowed to connect or not allowed to connect. Is the username password is correct or anonymous user connection? So in the session time only, it verifies authentication and authorization. Authentication and authorization also happens at session layer. Okay. So what is the creation of session means it's once you are request a connectivity, request for something like I want your web page, I want to upload a file, I want to access my mails, or I want to send a mail, I want to synchronize my time. So first it is understand who are you, is allowed to give access, not allowed to, like authentication and authorization, and it create a session. So with the session ID, so the communication happens like a with that you are sending a request and you are getting a response from the server. The total communication happens till you are loading the page or till your total communication is completed, till you are exit from the connectivity, the session has to be maintained. Session has to be maintained. How it will be maintained? Based on the session ID only. So based on the session ID only. Guys, if you remember one thing, that is when you are purchase something in the online, either through web browser or mobile phone. So you done a payment, right? So when you are doing a payment time, mainly in the payment time. So once you are given the details, you click OK. So it will shows do not, okay, do not refresh, do not refresh page or don't click back button. What is this? Do not refresh page. Why it is showing don't refresh the page? Okay. Why it is showing don't refresh uh, the page like this. Transaction is your order is processing. Do not refresh or black button. So what will happen if you do it? So there is a new session will be created. So for example, your entire transactions happens with us one single session ID only. Till the transaction completed, you have to do it in one session ID only. If you refresh or you press the back button, what will happen? The session will be changed. Your different session will be created. And your bank, you are sending a request to the bank, cut the money, and money will be detected. That information has to be come to you. But meanwhile, you refreshed. So then what happened? The session is disturbed, money is detected, but order is failed. Okay. So that is happens with your session ID. Okay. Even you download a something like I have downloaded 100 MB file, 99 MB is downloaded. Meanwhile, internet is got disturbed. So what happened? You cannot download remaining 1 MB. You have to download from the starting. Okay, because entire session has to be complete within the session time and with the session ID only. You take a bank, so you open the bank account. So if you go for a net banking, okay, go to iccibank.com, given a username and password. You log in and you have to do some transaction. You have done, then you log out. The session is completed. Sometimes you are searching like that, and you forget some ID, then you are taking time. Automatically, it will log out. Why it is automatically log out? It will give us some session time. You create a session, and the session is started. Within the 3 months, you have to within the 3 minutes, you have to complete. Within the 3 months, you don't complete, session timeout. It close. Okay, that is the session layer is doing that one. Understand, guys? The session layer. Okay. Next one is the transport layer. What is the transport layer duty is? Provide end-to-end connectivity. Providing end-to-end connectivity. It means the main form, it is between the software layers and hardware layers. So this is the way it is understand, like what protocol you are using and what application connectivity, okay, what data you are sending. So those things, whatever you use it, it start from transport layer to transport layer only. Actual data is will be reformed. Okay. At the transport layer, the data will be segmented. Data will be segmented. It means it chop the data into small pieces. Chop the data into small pieces. Okay. For example, I'm sending a packet called hello. How? Sorry. How are you? This is my most common example always. Okay. I'm sending this data just for our understanding, guys. It chop the data into small parts. Why it is? Instead of sending entire data, so if you are sending entire data at the receiving end, if data is corrupted, again you have to send it. Again you have to send it. So right? So instead of that one, it chop the data into small pieces called a segmenting. It segment the data. Once it is segmented, it put a numbering on it. Just for our understanding, I'm putting some numbers on it. So in the sequence order. When you transfer the data from source to destination, the destination will receive a data and give acknowledgement according to your packet. So first packet is sent and it is received because I received a acknowledgement. I understand the 1/4 is received. I send second one, destination is received and the destination give an acknowledgement. To send third packet, okay, and destination is received or not, we don't know because it's no acknowledgement. Fourth packet is sent, fourth is received, and it is sent an acknowledgement. So you understand the first one, second one, fourth one is received, the third one is not received by source. What is that one do? It is sent and we received an acknowledgement for the third one. So according to this packet data, arrange the data here it is. First one is hello, second one is how, third one is you, and fourth one is R. Okay. What happened? Order is changed. But because of this sequence, it will be rearranged back again. So as per the sequence order. Hello, how are you? Okay, it will be rearranged. So that is what happened with the transport layer. That's why the transport layer, so it is error correction will happen at a transport layer. It will rearrange the data in the transport layer. That's why end-to-end connectivity. Whatever the data you are sending, you chop the data at transport layer. At receiving end, at a transport layer, will add all the data, rearrange the data completely. Guys, understand?
Yes, sir.
And it multiplex or demultiplexes of TCP/IP protocols. What is this? TCP UDP protocols multiplexing kind of stuff. Look at here. So guys, we discussed about a protocols. Okay. And different protocols we discussed like a HTTP, SSH or Telnet, SMTP, right? So different protocols we discussed. These protocols either TCP type protocol or UDP type protocol. Okay, some protocols are both. For example, you take DNS. DNS is a TCP type as well as UDP type protocol. You take TFTP protocol. It is UDP type protocol. You take NTP protocol, UDP protocol. It is DHCP, UDP protocol. It is. You take HTTP, SMTP, SSH, Telnet. These are all TCP type protocols. Are it. What if a protocol is TCP type protocol? What if a protocol is TCP type protocol? When you send a packet to the destination, you send a packet from source to destination. When destination received it, destination sent an acknowledgement. TCP type protocols works based on the acknowledgement. So when it is send a packet from source to destination, destination gives an acknowledgement. So once destination receive, the source understand destination received a packet. Like source send a packet to the destination, destination received, it will send an acknowledgement. And source understand destination is received a packet. Like that, the communication is happen. The same way, okay. If in case source does not receive an acknowledgement, source does not receive an acknowledgement from the destination, it thinks destination not received a packet. So what it will do? It can able to send the packet again, once again. And if it is received an acknowledgement, and yes, the packet is received. This is the behavior of TCP protocol. And what is a UDP protocol? Of course, guys, there is a deep explanation of TCP UDP is there. I'm not doing that synchronizing kind of stuff. If you want, you can try something in YouTube, okay? But I'm taking normal way. UDP type protocols, source and destination. For example, I am TFTP, NTP, DHCP, source and destination. I send a packet to the 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 destination. Whether packet is received or not, I am not knowing anything. I will send destination received or not, I don't know because I'm not receiving any acknowledgement. At the destination side, any errors are occurs, then it will search. Some error is occur, again it will try to resend it. Okay. So UDP type protocols does not know about destination is received or not. TCP type protocols, the source knows the destination is received packet or not based on the acknowledgement from destination. Okay. So it is acknowledgement based protocol. TCP means transmission control protocol. UDP means user datagram protocol. Okay. In UDP, we don't have any acknowledgements, but in TCP, all are acknowledgement based protocol. TCP is kind of reliable. and UDP is non-reliable. TCP also called as connection oriented, UDP also called as connectionless. Why it is, guys? Some people think, even in my college itself, they said connectionless means wireless, connection oriented is wide type. No, guys, connection oriented means the source understand destination received a packet based on the acknowledgement. That's why it is reliable and that's why it is connection oriented. Okay. So UDP does not know destination received a packet or not. That's why it is non-reliable means source don't know destination received or not, and also it is called as a connectionless. Except that one, there is no additional thing. Okay, this is encapsulation or a multiplexing or demultiplexing of TCP UDP protocols. And this is the most common question again. What is the difference between TCP and UDP? Simply TCP, transmission control protocol, UDP, user datagram protocol. Certain protocols are TCP type, certain protocols are UDP type protocols. TCP type protocols works based on the acknowledgement. Source send a packet to destination. Destination returns an acknowledgement to the packet. So source understand destination is received. So TCP type protocols knows source knows destination is received or not. UDP source send packet to the destination. Destination does not send any acknowledgement to the source. So source does not know destination is received a packet or not. TCP is reliable because of source knows destination is received. Okay. UDP does not know source is received. Connection oriented. Why? Because of source knows destination is received. It will ask destination you received or not. Send me an acknowledgement. If it is not received acknowledgement, then thinks destination is not received. It will resend the packet again. Okay. So in UDP, it does not know destination is received or not. It send an error. So obviously then it is maybe react. So that's we don't know about that. Okay. So but TCP is a not faster than UDP because TCP always depends upon acknowledgement receiving. Okay. UDP don't wait for an acknowledgement. It keeps sending the packets. Okay. So this is a most common thing in this one. And what is happening in the transport layer? For example, I'm using different protocols in the communication. For example, I want HTTP as well as NTP. And there is through STP, then also I'm using SMTP. Over HTTP, I'm using SMTP. So what it will do? It encapsulate these packets. It's a TCP connection and UDP connection only. It's these protocols won't come outside. This is encapsulating under TCP. This is encapsulating under UDP only. The packet is like that. Okay. And transport layer also doing flow control. What is a flow control? My PC is 1 Mbps connect, 1 Gbps connection, but destination is 100 Mbps. Okay, the destination port is 100 Mbps port. So I can send very fast data I can able to send, but receiving end, it cannot able to capture all the data. So if cannot able to capture, it drop the packets because of the port cannot able to receive it. So what you will do? So the transport layer is estimate. So how many packet data units it can able to receive at a time of um, at a time. How many packets it can able to receive at a time. So that is it will estimate based on that it will give. Okay. So this is up to transport layer, guys. Here it is one point that is the most common point is PDU. So whether you are using any layer, it is application layer has the data that is application layer has a data. So that data we call it as PD. What is a PDU? Packet data unit. What is the data? Whatever the data it is, format of the data it is, in the layer we call it as a PDU. For example, presentation layer. Data is compressed, encrypted. Okay, data is compressed, encrypted, converted, like encoded. So that is the PDU. Okay, this data, whatever the data in the layer, and it is PDU. So each data it is transfer. This PDU is sent to the presentation layer. Presentation layer data is sent to the session layer. The PDU of application layer, presentation layer, and session layer is called a data only. But at a transport layer, this PDU, which is we are received PDU from there to here. Okay, what will happen? Data is segmented and sequence number is added. Okay, and TCP UDP multiplexing is happened, and flow control information is also added. All this information is added to a TCP header to our this PDU. Okay, so this total one we call it as a segment. This total one we call it as a segment. What is a segment? The data, the PDU which is coming out of transport layer. Okay, this segment will be going to the network layer. Here it is. TCP header is added to the PDU, which is from the session layer. Okay, this total one we call it as a segment. This segment PDU is sent it to the network layer. The header is having a information about segmenting, numbering, protocols information of TCP UDP encapsulation information. Okay, guys, understand somewhat? Try.
Yes, sir.
Okay. From here it is very easy because transport layer is very bigger. From here it is easy. The network layer, again 2 points. One is routed protocols and another one is routing protocols. What is meant by routed protocols? About a logical addresses. IP address, IPX, SPX, AppleTalk kind of addressing schemes will be added here. Of course, we use IP addresses only. We don't know about remaining IPX, SPX kind of communications, right? So we are using IP addresses, either IPv4 or IPv6 kind of IP address as a logical address, routed protocols. Okay, routing protocols. What is routing protocols? As I said in a routers, they use the routing protocols to build the routing table. So routing tables will tell how to reach the destination. So it is contains information about how to reach the destination. Is it a same network? Is it a different network? Is it a the destination is in a different network means how to reach the destination, how to go to the default gateway, from default gateway, how to go to the destination, like that. Routing information means how to reach the destination. Is it the same network or different network? If it is the same network, how to reach it? If it is a different network, how to reach it? That routing information is available here. So routed protocol means IP address, source IP, destination IP address. Source IP address, destination IP address, and routing information will be added to the your segment from the network layer. So this is we call it as actually packet. The actual packet contains source IP, destination IP address, of course, the routing information, required routing information side. So normally source IP and destination IP address. And this is called a packet will send to the data link layer. Okay, data link layer. And data link layer again 2 parts, LLC and MAC layer. LLC and MAC layer. What is this LLC layer? So when you are connected to the WAN connectivity, okay, it is a layer 2. WAN protocol is layer 2 protocol. Say WAN connectivity means I am in the organization. I have my servers and all things are there. Network is there inside, but I want to connect it to my remotely, and I want to connect, or maybe I want to connect it to the public. I have to connect it to WAN only. In a point-to-point WAN connectivities or point-to-multi points WAN connectivities. So they use this LLCs even for a WAN over internet like a public. Okay, one on the public, it is like internet kind of stuff. We use this layer will helps us to connect. Internally, LLC is not there, but externally, like when you are connecting from your LAN to WAN, so that's your end device which connects to you to the WAN. So that will understand this LLC. Okay, LLC protocols are frame relays, PPP, frame relays, SDLC, MPLS. These are all WAN type of protocols. PPP, point-to-point protocol it is. Okay. So when you are connected to the WAN, then WAN related information, WAN related protocols will be added. Okay. So next one is MAC layer. Layer 2, MAC layer. It is MAC layer is there. Media access control, we know where is the MAC address on your NIC. It is 48-bit represented in 12 hexadecimal. Okay. In a data link layer, there is a two things will be added to your PDU. So what is it is? This packet is came here, but you will adding source MAC address, destination MAC address, and packet, and there is a CRC. Plus, if it is a WAN connectivity type, the it is that what is the type of protocol we are using, and their authentication information also will be added here. Okay. In generally, we are not talking about WAN, then it is only source MAC address, destination MAC address, your packet from the network layer, and CRC. Okay. This CRC means cyclic redundancy check. What is CRC? Cyclic redundancy check. What is the use of the CRC? It is an algorithm. It generates a code from the our data. Whatever the data is here, from this data, it generates a code. At destination, when destination received a packet, it verifies the data using CRC code. It use CRC value to verify your data. Data is good or corrupted. If it is corrupted, then it drop the packet. Okay. So this combination we call it as a frame. This frame is sent to physical layer. This frame is sent to the physical layer. Okay. So in the data link layer, error checking happen. Where is error correction happens? In the transport layer. Error correction happens at a transport layer. Error checking happens at a data link layer. At a data link layer using CRC algorithm. It verifies about your data packets are good or corrupted. Okay. So this total PDU, we call it as a frame. The frame will send to the physical layer, and this frame is converted into bit stream. The frame is converted into bit stream. Bit stream again converted into electrical signal or radio signal or light wave signal, depends upon the type of connectivities. So this frame converts into bit stream and depends upon what type of connectivity you are using. You're using a cat cables like a Ethernet type of connectivity, then it is electrical signal. If you are using fiber optical type of connectivity, light waves. Means that adapter is depends upon the adapter kind of stuff, right? Depends upon the device connectivities. If you are connected to Wi-Fi kind of stuff, it is radio signal like a 2.4 gigahertz or maybe 5 gigahertz type of connectivity. Okay, so that's the point here. One line disturbs everything. See, one single line. Add this single line, then it disturbed the overall stuff. Yeah, I will reduce by this. Now I can go to this. We'll move this. Nothing. Still it is here. Mhm. Okay, now it is good. It is good. Yeah, finally, it is good. Okay, guys, understand what is the physical layer, data link layer, and the network layer. What is a CRC? What is the purpose of CRC kind of stuff? Hmm? Non-speaking?
Yes, sir.
Very good. So we are every day, we are told to leave at 4:30 like that because you are having a test and all. But it is not like that. People are already from 22 members to only 12 members. Okay. But I am have to continue because it's a big lengthy one, and if you are not completed, you won't get a time for other chapters because other things also there is a good questions also there. And of course, network troubleshooting is still left. Okay. So Monday, I'm going to take care of this network related troubleshooting. And if I have a time, then I will try to tell you some other troubleshooting like a hardware troubleshooting. Then we can continue with what is server services kind of stuff also. Okay. So we'll see that one also. So we'll continue, guys. So just keep listening. Source side, if you are sending, the first layer is application layer, presentation layer, session, transport, network, data link, and physical layer. Okay. So here is also same thing like application layer, presentation layer, session layer, transport, network, data link, and physical layer. Guys, for example, I send a request or upload a file. What happened at application side, client side application. So then I choose protocol application and what is my destination from this source, right? So I have to choose my what application I have to use it, what protocol I have to use it, what is the destination address. Okay, yes, of course, destination IP address. Okay, then this data go to that information go to the presentation layer is that the connectivity is required encryption, it encrypt it, and then data is encrypted, data is converted into the ASCII format, encoding, first is encoding, compressed, encrypted. Three things will happen. First is encoded, compressed, and then encrypted. And session will be established. So this is the which username you want to connect, what is his password, and so like anonymous user or if there is specific user kind of stuff, and what is the session ID it is. It creates a session. Okay, it create a session. That information go to the transport layer. And transport layer it segment the data. Whatever the session layer data is there, it take it, okay, up to whatever the data is there, it segment, it chop the data into small pieces, put a numbering on it, what protocols, put it on TCP, UTP, encapsulations, and encapsulations. Okay, then it is a segment. This is a segment. This segment sent to the network layer, understand what is the source IP address and what is the destination IP address, add it to the segment, and how to reach the destination information. That is also, it will be added here. And this what we call it as a packet. The packet, to the packet, it adds source MAC address, destination MAC address, and to the packet, right? This is what we call a frame. The frame is sent to the physical layer. Okay, the frame is sent to the physical layer. In the physical layer, so what happened? It convert into the bit stream based on what type of connectivity is. So it will convert into that type of signal it is. Think like this. It is normal Ethernet type of connectivity. It convert into electrical signal. That signal is finally reached to the destination where physical layer to this port. So this physical layer understand what is the signal it is, convert the signal into bit stream and convert the bit stream into frame. Convert the bit stream into frame. The frame will send to the data link layer. Data link layer verifies source MAC address, destination means A's MAC address and B's MAC address. Both is verified. Okay. What it will do, it keep this A's MAC address aside. First time it is communicating, it keep a MAC address side in one place called ARP table. Okay. So first it verifies source MAC address, A's MAC address, destination MAC address, B's MAC address. Is it meant for this system? Yes. Then accept the packet. And it contains this remaining is packet. And it use CRC to calculate data, is make sure that data is not corrupted. If not corrupted, accept it. Corrupted, drop the packet. Now we got a packet. This packet is go to the network layer. And network layer, it opens the packet. It contains source IP and destination IP. Means A IP address, B IP address. Is the B IP address is same as this B IP address? Yes. Accept the packet. No, drop the packet. Okay. So, and it saves this AIP address. Okay. It saves AIP address. Keep it side, guys. We'll talk about this one. Okay. Like this. Now, source IP, destination IP is removed from your packet. What is the remaining? Is a segment. The transport layer collect the segment and verifies the segment number. Again, lot of packets are coming, right? Lot of packets because it is segmented. It chop the data into small pieces. All the pieces will be comes to here, and these all transport to the transport layer. The transport layer, what it will do? It arrange all the segments into the order and make it as a one single packet. Okay, and it opens that protocols. What are the protocols are you using? What is the segment sequencing? It arrange it. Now we have a data that will be sent to the session layer. Session layer verifies who is going to be connected, who required, okay, is allowed to access, not allowed to access connectivity. The segment will be decided. Sorry, session layer will be decided. Then it verifies and save the session ID. What are the session IDs created here? That will be saved here. Okay. And then remaining information will be sent to the presentation layer. In presentation layer, data is decrypted, decoded. Okay. In presentation layer, data is decrypted, decoded, and decompressed. Okay. Then finally, the main data go to the application part. For example, as I said, if I want to access a website or you want to upload a file or want to send a file or like that, it is if I want to send a mail. So the application part of that destination will understand what is your protocol, what is your request. Based on that, where's the things has to be there, what application has to be respond according to it. So that application layer will understand that one. So then it will do all the your verification information and give a reply. Again, in a reply, application to presentation, session layer, same session or not. Within the same session, it will reply segmenting data, adding IP addresses, adding MAC addresses and CRC, convert into frame, and then finally bit stream to this, and from here to here, here to here, here to here, like this, it is a communication. Like when you are sending, like this, application to presentation. At receiving side, presentation to application. Again, when it is sending, like this. Okay, this is again like this. Okay, so guys, understand from source to destination how packet is traveling. Oh, no responses. Address resolution protocol. Address resolution protocol. What is meant by this one? It create a table, and in the table it write the IP address of remote system when it is received a packet. When it is received a packet, it note down the IP address of that packet and IP address of the system or a device and MAC address of it. It is make use to communicate again, because when you are communicating, you communicate with IP address. You don't mention the MAC address. Okay. So when these devices are communicating each other, they learn their IP addresses and MAC address. So next time they are communicating, they use the specific MAC address. Okay. So don't worry about it because no one is speaking. Okay. So understand up to here, guys, this part.
Yes, sir.
Okay.
Yes, sir.
The very last one, just 2 minutes, maximum 5 minutes, I'll complete. Guys, we are all using TCP IP protocol suite. This is also called as DoD model. Okay, DoD model. This is like a defense model. At the time of US defense model, they use this in a defense. Okay. DoD model is similar to TCP, but it combines application presentation session layer into one layer. It uses different name for transport and internet layer. DoD is basically original TCP/IP protocol. Okay, so DoD model or a TCP/IP model is same. Earlier we use it is for a defense. Okay, not Indian defense. Okay, all are generated from US military only. So America largest government agency, Department of Defense model it is. That is different part. Okay, so it's a different model. Here it is application transport, internet and network access layer. You have 4 layers in the DoD model. And the next one is if you are compare OSI layer to TCP IP model. Okay. Actually, TCP IP OSI model is not used. Sort of people think from OSI TCP model is came, but this is a comparison, not extraction. Okay. It is not, it's just a comparison. understanding of OSI layer. Okay, it's just a comparison. And really, OSI model directly, our system don't use OSI model. We are using to understand network functionality and for troubleshooting purpose. Okay, TCP/IP model contains application layer, transport layer, internet layer, and network access layer. The application layer of TCP/IP is actually combination of application, presentation, and session layer. Means these three layers of OSI model, what are their roles and responsibilities of these three models, three layers will be done in the application layer only. In TCP/IP, the application layer will do all these three layer work. So it's a combination of application, presentation, session layer. Transport is transport. And here it is, internet layer is nothing but a network layer. Network access layer is a combination of physical layer and data link layer. Okay, that's why I put a color manner. Network layer is a combination of physical and data link layer. Internet layer is nothing but a network layer. Transport layer is nothing but a transport layer only, but application is combination of application, presentation, session layer. And we are using NIC card. NIC card we are using, right, for connecting to the network, right, as a wider wireless type of connectivities. It's a nothing but physical connectivity plus there is a MAC address in it. Okay, so here it is as a TCP/IP, it is comes under network access layer. It comes under network access layer. Our NIC cards, LAN cards, okay, all these things, wider wireless type of cards comes under network access layer. Okay, this is the comparison between OSI and TCP/IP model. Mhm. Yeah, we have a something like a troubleshooting using OSI model. Okay, so how to do the network troubleshooting, connectivity between the devices, how to check the connectivity. Okay, if there are not connected, how to troubleshoot. Those kind of stuff is there. Plus, IP address related troubleshooting is also given here. Okay, in this one. Okay, layer wise troubleshooting kind of stuff. And a Wi-Fi router configuration is also there. These are all we'll discuss on Monday. Okay. And from Tuesday, we are going to discuss about the servers and services. Monday, the network part will be completed, guys. Okay. So layer wise means if you understand each layer responsibilities, so if you have got any network related issues, we can able to understand. Easy way to tell, see, physical layer, like two systems are connecting or not communicating or not. It means first you have to check the, if you they are not communicating, first check the physical connectivity. Both are physically connected or not. Wider wireless, first is connectivity is important. Next one is IP address. Both side IP addresses configured in the same network or not. Same logical address. Both are in the same LAN. Means their IP address must be in the same logical address. Both are in the same physical network. Means their network also, their logical address also same. Okay. It means one side 192.168.1.10. Another side 192.168.1.11 or 11 to 12. Means their network portions must be same. Okay, both side IP address must be there and their IP address must be in the same logical address, same network address must be there. Okay, so that is also an important, right? So if two systems are not communicating each other, means check the physical connectivity. Next one is IP addresses, and then both IP addresses are good, both side IP addresses are good, both are in the same logical address and no conflicts are there, then check with the firewall. Maybe firewall is blocking your connectivities. And your type of communication is maybe encrypted or maybe depends upon protocol. Both side, you have to check the protocol type of communication. As I said, I'm using a web browser. I want to upload a file with a um, SMTP protocol. May not work. Okay. So it's a WAR protocol, means the protocols you have to check it, and as well as they're encrypted, like a, what we have to say. That's a TLS. That's what is showing now. Okay. So what we have to say it is, um, if it is encrypted, use encryption. So, and date and time synchronization, encryption certificates are important. And you must complete the transaction completed within the session only. Don't press the back button kind of stuff. Okay. So application layer. So both side. So what is the meant for what type of communication? That related application must be suitable and protocol must be suitable. So guys, this is, if you understand OSI model, depends upon the issues, depends upon the rules and regulations. The communication is happened at. If you got any issues, we can understand where it is, and based on that, we can take an action. Okay. So today is a Friday anyway. So to Monday, so we are going to discuss about a troubleshooting and Wi-Fi setup related on Monday. So once it is finished, then we'll go for a remaining chapters. Okay. Remaining modules also. Okay. That's it for today. Anything, anybody want to say anything? Final words of today's class? Okay. Thumbs up only. Okay. Yeah, that's it for today, guys. Thank you. So Monday onwards, mostly I will go after 4, 5, 5:30 also.